Perfect. We are live. Welcome back, everyone who's joining us, who have joined us before, and all of you who are new and watching us today. This is our fifth session of the Quick Unpack with Q-PAC. Today's topic is going to be hospitals and medical facilities. I have the one-stop shop of Aaron Levy here with me. He's our sales manager. He's got a lot of industry experience, and he's going to bring a lot of new and fun energy to the presentation today. So I'll start with a few of our announcements right at the top. We're still looking for people to come to our Quick Unpack Summit. We have a few spaces left. That is going to be October 18th and 19th. It's a great hospitality event we will be hosting at our facility in St. Augustine in October. A great time as the weather starts to change to come down to Florida. We're going to have keynote speakers. We're going to have product demos. We're going to have great networking events for everybody to kind of join in for. So look forward to that, and reach out to me if you'd like any more information. Our email at the top, marketing@qpac.com, is a great way to reach out directly to me. You can use our comments over in the comment section. Any questions that you have, any thoughts, ideas you want to share during the presentation, please put them in there. I will interrupt Aaron when I can, and we will ask those questions live. Or Kurt Thomas, one of our engineers, will be able to handle those questions in the chat. On top of that, let's bring Aaron in, and we will begin the presentation.
All right. Good afternoon or good morning, depending on what time zone you're present in. Again, my name is Aaron Levy. We're going to be talking about operation hospitals, medical facilities. It's a huge vertical market for us. And today we're kind of going to go over some of the application demands, how Q-PAC integrates in, and some of the problems we solve. We're going to talk about installations and the repair side of it, and kind of finish things off with a little bit of ROI talk. It's a very big topic for a lot of people about saving money. So we want to make sure we hit that because it's a great selling point for doing retrofit solutions on those. So we're going to start off by talking about hospital HVAC demands. It varies in their applications depending on where you are in a hospital. Some of the pressures can go anywhere from 1.5 inches up to about 9+, depending when you're looking at clean rooms and some operating rooms and things like that with all the HEPA filters that they have in line. And a lot of these systems can be really complicated where they're located, and being able to shut down. Limited downtime is a huge thing for these hospitals that are near capacity or past it. So a lot of those things could be operating rooms, critical facilities, patient rooms, data center cooling. A lot of them have those on sites for larger systems. As well as the common areas. And so, depending on what we're doing, depending on the HVAC demands, it can vary, and we have a solution that'll really work for just about everything that you can find in a hospital. And when we're talking about demands, during the COVID era, a lot of hospitals were pushed to their brink. A lot of people before COVID, had wings of hospitals they would shut down because they weren't using them. The demand wasn't there. And so as we went through that pandemic, you watched a lot of hospitals be at capacities. And this map kind of gives you a little snapshot, depending on where you live, about how your hospitals probably were at their limits or higher. And a lot of those HVAC systems were taxed to their limits. And some facilities do tend to be a little reactive versus proactive. And instead of doing the maintenance or planning for repairs on systems that have had multiple failures, that they would wait till something would break. And when systems would fail, having something that was a quick turnaround was a very important. Doing quick ships, making sure we had fans in stock. And we were very integral for a lot of hospital projects, and it turned to be one of our greatest vertical markets, and it still is. And so we always talk about hospital maintenance because where does it end? If you've been in any of these facilities as a mechanical contractor or a rep, you've seen their wall of belts, and a lot of that equipment that's getting older, those belt drives and pulley components. They're always needing some kind of greasing or changing belts. They'll squeal down. You can hear them when you walk in the mechanical room and they start up. And all of that just leads to constant maintenance over time. And with the Q-PAC system, we can eliminate a lot of that from a factory or for facility, and it'll save them in terms of their maintenance cost every year for their labor and for the components themselves. It saves them from lost revenue because once a system's down, a lot of these belt drive systems, if you ever lose the shaft or a pillow block bearing, or even the motor, sometimes they're not just readily available sitting on the shelf, and you could be down for a few hours to a few days, depending on how long it would take you to install those components. Then you obviously have customer complaints, and then of course their energy usage. They do tend to be energy hogs. They still have old VFDs, so they're just not as efficient as a newer EC fan system. So again, those things that you always have to worry about: greasing bearings for the shaft or the motor itself, having to adjust tension on belts on a regular basis as the pulleys as the belts slack up a little bit, having to adjust pulley diameters as you change belts, and moving motors and positioning. So all of that stuff makes a huge difference in the day-to-day operations of that hospital, and by eliminating that, to keep them up running and having more redundancy in the system is a huge win for them, not just from the energy side of it, but also from a maintenance point of view. And when we're talking about aging equipment, a lot of these facilities that are older, I would say that's 20 plus years old. A lot of the equipment were built in equipment rooms that the building was built around, and there was no thought given about how you would get this equipment out of the spaces. A lot of times when they do these retrofits, the team has to go in there and cut these things out in pieces. So you have to go into mezzanines, basements, tight doorways, stairwells. We went to a facility here in Charlotte to go look at a job, and you had to kind of go down the basement, through part of an air handler system, through another door, through a second set of doors, and then all of a sudden there you were, 20 feet below the surface of the facility. And how do you get this thing out of here? And so this is where Q-PAC really comes into play as a huge win for those facilities, because everything is modular and hand carryable into these tight spaces. The widest component is either going to be the disconnect itself or even the fan. And most of those will fit through all standard doorways under about 21 inches. The heaviest component tends to be the fan. That's less than 150 pounds. So a team of 2 people most of the time can carry them in. The average weight of those tends to be between about 70 and 100 pounds. So it's really great for retrofitting out old systems, regardless of whether it be a penthouse style unit or an old air handler or anything in between. And it makes a lot less labor on impact on the building by being able to carry those things into tight spaces. And then when we talk about like Q-PAC and hospitals, it's just a natural, successful point. We've done hundreds of hospitals across the country. Our system, it gives a peace of mind to not just the maintenance, but the building owners alike. Because having a fan array system inherently builds in redundancy. In the event of a fan failure, that no one's stopping the world to run over there and fix the system. In most cases, we have an N+1 performance setup that we configured when the building was designed or when the retrofit was designed, that as the fan fails, the occupants don't notice it, the building owners don't notice it. And so when there's a safe time to shut the system down, it takes less than 30 minutes for a team of people to go in there, pull the 8 bolts off the fans, disconnect the wiring harness, put a new one back in place, plug it in, turn it back on. So even critical spaces like operating rooms where they have very tight windows, depending on what's going on in that day, that, in between surgeries, there is a time for cleanup that you could, if they had to have that full capacity back, that could be changed in between surgeries. And that's a huge win for those, that even if a fan went down during a surgery, that it doesn't stop the operation or doesn't affect the people inside. A lot of things we can do is build continuity into an entire facility. And instead of having 5 to 6 different motor sizes for every different application, you can end up having an entire building with 1 to 2 part numbers. So it keeps parts down for the building owner. They only have to carry a handful of parts that work in every air handler system that they have that has a Q-PAC system on it. So instead of having multiple fan motors with multiple pulleys, multiple belts, different pillow blocks, uh, everything is just one fan part number. And all the controls inside those controllers are all the same, just depending on how many fans we add in a system. So everything becomes very much universal. So it allows a lot more continuity for a building. And of course, like we talked about, lower downtime. Even facilities that sometimes the system's oversized, that were maybe a fan or two heavy, that you could lose one, maybe two fans in a system and still be at full capacity for your occupants never to even notice the difference. And then when it comes time to shut those things down for a minimal amount of time, you're talking less than 30 minutes to repair a fan and then move on with your day. So the impact to the people inside that building and that facility just aren't really feeling the pinch points as you did with belts or pulleys, where you lose a belt system and you'd be down for a couple of hours until somebody could get up there, get it all changed out, or God forbid a motor goes out or drive, that there's no backup for that particular system. And we talk about risk versus rewards. When a system fails like this, like an existing double width, double inlet blower or a vane axial or something like that, I'm like, when those things go down, the impact cost of that building is immense. It's not easy to move people from one side of a building to another or to reschedule surgeries. This hits their bottom line. It just really creates a bottleneck. And being able to eliminate that with a Q-PAC system, there's no risk. And when we're starting looking at having to try find people that can even rebuild these wheels or these motors, there are very few people out there that still can make this particular size equipment. And even if you found somebody to do it, it's still not cheap. Lead times are really long to have custom shafts made. If you ever just if you spin a shaft or you throw a wheel, the cost difference between repairing that equipment and replacing it with a Q-PAC system is come a lot closer. If not flipped more for a retrofit, tends to be not just more cost effective from the labor side of it and the equipment side of it, but also from the energy side that goes on to the post installation side of it. So it tends to be a no-brainer. Once a hospital or a facility kind of switches to a system like this, they tend to really appreciate what it offers the building as a whole. We have a facility in Lubbock, Texas, and we've done a few of theirs that we started off as just doing a couple of retrofits. And out of their 36 air handlers, I think we've done now 30 with Q-PAC systems in it. And by the next 2 years, I think we will have had every air handler in that system will have a Q-PAC system in it. It allows them to be very focused on their energy usage. It's cut down their maintenance cost by a huge number, and their downtime for anything has almost gone to zero. So at least when it comes to the fan side of it. And that's where even switching from doing not just the air side, but even adjusting, looking at a cabinet that's still in really good condition, replacing a coil and a fan system together can extend the life of that system another 5 to 10 years. So it becomes like a third of the cost of having to replace a system, especially when you take in some of the engineering costs that it would take to maybe get some of that old equipment out of the building, given that the location it may be in. So I see a question really quickly. It's over here in my peripheral about MBTFs. So one of the big questions people ask about EC fans is about their life hours. And so the average, what we call the L10 or 10% field failure rate, is somewhere between 50 and 80,000 hours. The MBTF, so mean time between failure, which really gets you into about the 50% range, tends to be 100 to 125,000 hour range. So somewhere between, when you're looking at the L10, 6 to 10 years. And as Q-PAC gives you a 5-year warranty, we're kind of in that range of the lifespan of that system, even for a 10% field failure. We've got it covered. So there's very little risk to the customer, even on that side of it, that they know that whatever system they're putting in with a Q-PAC system isn't just warranted for a long period of time, more so than you would get with any other component. that they have the support that will go with it. And we keep those fans in inventory. So we don't tend to worry about supply chain as much as other people do, because this is all we do in this industry is build fan arrays every day. So at any given point, we have a couple of thousand fans sitting on our shelves ready to go. And that's just on the sales side. If we're talking about the support side, we keep a support stock separate from sales, just for emergency replacements. So the fear of having to wait weeks upon weeks or months to get a replacement fan is out the window, that we take that on and keep that inventory for us. That's a great question, because it happens all the time where people ask about life hours versus a motor. So we always say, like, in with the old and out with the new. I mean, a lot of this technology has been around for 20 plus years now, this ET technology. It's ever changing. That we're on the third, fourth generation a lot on some of these electronics, and everything just keeps improving, getting better and better as time goes on. And this older equipment is going the way of a dinosaur. I remember when I first started in the HVAC industry, VFDs were just really coming onto the scene, and everybody was kind of using them and having to get used to them, and nobody really liked them because it was something new that we never had to deal with before. And now they've become the industry standard for as long as as I've been around. And now EC technology is becoming that linchpin that is now going to be that new industry standard. A lot of OEMs are switching to it. They're lighter. They're now the cost effective at this point, not just from the energy side, but from the material side of it, of having to make their cabinets a lot smaller. So I believe like a lot of people will see this in the industry going forward. As they buy new equipment, we'll end up with these systems in there and retrofitting them out. Now it gets them ahead of the curve. So what we don't talk about Q-PAC integration, by getting into what problems we solve by switching from the existing system to a Q-PAC system. And when we talk about a Q-PAC system, it is a fully engineered product. It includes your bulkhead wall that's custom built for the particular space that we're going into. It includes all your wiring harnesses from the fan sides, all the controls, the fan models themselves. And the only thing, we even send you the sheet metal screws and zip ties to put everything together. Short of like a team showing up with an electric drill, a 5/16 chuck for the self-tap screws, a 1/2-inch chuck for putting the bolts in for the fans, and a pair of side cutters to cut the extra zip ties, there's very little more that a team needs to show up for. The only thing that we don't provide in the scope is the power and communication conduit between the disconnect and the quick connect box or boxes inside the array. That's done by an electrician, but it's minimal connection points that they have to do. So it does allow a team to install one of these systems, 2 to 3 people, less than 8 hours in most cases to install a system. We have an example later on that there was one, they did it in 4 hours. And it's very common when we're looking at systems of 9 fans or less, that a lot of these systems can be installed in less than a day. So we talk about these components a little bit more. We have a custom bulkhead wall. So we take the internal dimensions of the space, height and width. We always say go floor to ceiling, wall to wall. Because what it does is it can work with any existing system. We're really only limited to static about 9.5, 10 inches. We can get up that far. But at that point, you're going almost even for even when it comes to energy cost when you're looking at an AC drive. But we add so much more redundancy and safety factors to the system, even with those higher statics. But then it's a matter of just putting airflow in a space. It can even be worked for open penthouse solutions. Sometimes an enclosure needs to be built by the mechanical contractor or the team on site, but then we can fit our Q-PAC system inside that enclosure. We can also configure them, if space provided, to add door for access to the coil side. A lot of cases when you're opening up some of these air handlers, the double width, double inlet blowers of the blower system in general has walking access or to the coil side. For doing any cleaning or maintenance on the drain pans and things like that. And by putting in one of these bulkhead walls, you do sometimes lose some of that access. And if there's enough space and we can move the fans around inside the array, we can even add an access door, which eliminates that ability to get to that coil. These can also be mounted in vertical or horizontal configurations. So depending on how old the system is, it could be an upblast or a downblast type system. So being able to mount it horizontally to fit into the existing space may be necessary. And we can do that as well. And again, we do a lot of our solutions are N+1. So being able to have a fully redundant system or near fully redundant system, depending on how we specify the system, a lot of times we work on a building's schedule print. And depending on how that schedule is written, it could be oversized for the unit, which allows us to either just already have inherent redundancy into it, or being able to even remove fans out of a system to be able to make that system even more efficient and have spare fans already on site built into how we've integrated that system together. So, and that's just inherently with how this wall design is, that we can just remove fans out of a system to make them, instead of like maybe a 5-pack, we can run it on 4 and put a blank off plate on. So those are just capabilities that we have without having to have addressing and us controlling every touch point of the control section.
Hey, Aaron, got a quick question to toss to you. Yeah, David is asking, have you guys ever run into big fans in these old buildings with larger 575 or 600 nominal fans? As far as I'm aware, there's no ECM fans available at this higher voltage.
That's correct. So 575 is very much a Canadian spec. Right now, no one makes one that's 575, mainly because this market, I used to work for the fan manufacturers for 12 years before it came to Q-PAC. So this is a very common question that I would get even at Rosenberg. The problem is that to do 575 would need a whole new set of electronics. And the way that the current electronics are built for each particular model, that cabinet height is only so big, and the capacitors needed for 575 voltage and stuff like that are so much taller than and all the other components that would be needed to handle that voltage won't fit inside that chassis. So a new electronics would have to be developed, and for such a limited market, normally we use step down transformers, and that normally is enough to get us through these particular applications. Even with OEMs, when we were selling EC fans into the OEM market for the Canadian market, they would often step down 575 to 460 or 480 and do it that way, and that seemed to be sufficient. I just don't see it on the horizon. I'm sure each manufacturer kind of has that in their playbook as a roadmap item. I just don't know if it's a hot button issue that'll happen in the next couple of years. Anything else?
We did have a request for a future topic, but if it's something you can touch on now, touching on FEG to FEI, but it looks like maybe that's something we need to give it depth and breadth.
Yeah, so that's fan efficiency grade and fan efficiency index. So really that's kind of, and I can touch on it really quickly because it's not too bad. To compare AC motors to ECs to kind of give them a more apples to apples playing field. The main problem is that EC and AC fans don't have the same power factors. So that's why sometimes we use FEI and FEG to kind of make them even. So we do have an FEI calculator in our selection software. We have the ability to send that out, and we can kind of give you what those numbers would be if requested. So yeah, one of the other things that we can do is we talk about our bulkhead wiring harnesses that we provide. So every fan is already pre-wired in the system. It's all tested. So that pre-wiring harness eliminates the installation process of somebody having to wire each fan individually. They also cuts out the touch point of somebody wiring something improperly. It takes away a lot of the labor cost of an electrician, because it's all plug and play. So even the most basic of technicians can just plug them in and goes right back to the quick connect box, and they're all labeled 1, 2, 3, or however many fans are in the system. So they're very easy to kind of navigate. There's no additional programming because that's all been taken care of by us. And even from a troubleshooting standpoint, it would be really easy to kind of find out if the wiring harness was bad, how you can measure across the ohm from one side to the other. So it really kind of takes your troubleshooting time down by knowing that the wiring harness may be not a point you need to look at. And it also keeps the system very clean and organized, because once those wiring harnesses are mounted to the bulkhead wall, you're not having to trace out wires all the time and figure out which ones are which. They're labeled on both ends of the harness, so you'll know exactly which point you're touching and to know which fan has failed. So if it says fan 1 has failed, you know exactly where that would be. And this is where it all dead ends back at our quick connect box. And this solves a lot of problems, from the installation side, because it is designed to be the power and distribution hub for the bulkhead, for the fan array itself. This mounts right next to the fans. It's got all your connection points for your power, your control, and your pressure transducers are in here as well. Mainly, this is more for the premium controllers that we offer, because it can read out CFM and back to the controller itself. The pressure transducer, I believe, is in all models, whether it be basic or premium at this point. It's not a very expensive component, but so we include it in everything going forward. So that pressure transducer will be standard inside that inside that quick connect box. Also, everything in there will have a fuse circuit breaker for fan isolation. So in the event that you need to isolate a fan for whatever reason, you can isolate it from that quick connect box. It does require going into the space itself. So a lot of times you have to de-energize the equipment to be able to go into there to make those disconnections. But again, it's a very quick process to be able to disconnect that stuff and then turn the system back on. And so all your connections are very basic, that go into, they mirror back from the main disconnect outside. So it's really your L1, your L2, L3, your ground, your communication cables, that gets mirrored back out to everything else. So it's very easy to land one point to another because it mirrors back to the control box outside. And then we talked about our control panel. That's the main brain of everything that we do. It's a very visual touch point. We provide a hand auto and off control. So in the event that you lose BMS or something happens to the PLC, you can switch that to hand mode. As long as the fans have their own, has line voltage going to it, the fans generate their own +10 that we can modulate with the local potentiometer. So that gives a lot of peace of mind that if for whatever reason BMS goes down, you can run that thing in hand mode and go. So what I always tell people, though, is that once that system is balanced and whatever that's operating in hand mode, that somebody writes that number somewhere on the disconnect. Mainly just because it's just a 0 to 10 potentiometer. It's a very linear control. So 5 volts of input would be half the RPMs of those particular fans located inside that array. What I don't like for somebody to do is turn that thing all the way up to 10, because depending on how that system is designed, you could get a very large rush of air through ductwork that may or may not be able to handle it. So I always tell you, somebody, to whatever that system is, to keep your system's efficiency and keep your airflow where it needs to, is to have that as a local reference point right next to the potentiometer. And for our premium systems, we do BACnet MSTP. Right now, we don't have an IP version available. I believe it is something on our roadmap that we're working on and that we would probably see in the not too distant future. But for the most part, MSTP does cover us for a large portion of all the solutions that we run across. Again, you get airflow and power monitoring right there locally through that 7-inch Schneider touchscreen display on the premium controls. And again, minimum landing points. The good part is that the safeties inside the fans allow for, you can't run them backwards. So for an electrician, it's very easy to just put L1, L2, L3 on any terminal you want. You don't have to bump start things to turn them over to make sure that the motor's going in the right direction, because the fans have a phase corrector inside them. So he just speeds in there, boom, 1, 2, 3, put it in there, put your ground on, turn it on, and you're ready to roll. And that's the same for the main disconnect as it is for the quick connect box. The fans will correct the phase and turn the fans in the right direction. So it's nothing that they have to go and switch 2 legs of power just to make sure it's in the proper phase. And this is just a kind of a picture of what the system kind of looks like when it's all together. This is probably about a 50,000 CFM system. I normally kind of figure about 3 to 5,000 CFM per fan. When somebody asks me how big of a size, how many fans would it be in a particular system, that's kind of my general rule of thumb. And that really depends on static pressure. But it gets you kind of in the ballpark. So you can see how the wiring harnesses are routed, and you can see the conduit here for that the electrician would have to do. That's the only part that an electrician has a touch point that has to be manually installed. But yeah, this is a typical system. We do supply a blank off plate as standard. We didn't go into that. We've talked about backdraft dampers in other unPAC series, but we do supply a blank off plate as standard. So in the event that a fan has failed and you want to remove it from the airstream, so there's no loss of fan just recirculating some air, that number is very minimal. It's roughly, I believe, about 3 to 7% of that fan's output if it's just left in the airstream failed. But if you want to remove it, the blank off plate goes right over that fan's slot, and then you lose 0 as a backflow preventer. So, any other additional questions as we go on to the next one?
We do have one more. How to control the fans with the controller for the sequence operation?
If I guess if he's asking if you can, Safar, I believe, if you're trying to say, can you sequence the fans in a series, like can you start some fans and then bring other ones on as like lead lag? You can't do that. Mainly because once the fans are spinning in a system, you want all the fans to ramp up and down at the same RPM. They keep fans from fighting each other. In a lot of ways, if you lose a fan or you take a fan out of line and then you want to try to bring it back on later, that fan will just freewheel inside, and there's not enough torque inside those motors to kind of flip them back around depending on the RPM that is spinning backwards. So sometimes you'll get a lock rotor alarm when it does that because it doesn't know what magnet position it's in. So normally we sequence everything up and down all the same. So if there's 5 fans in an array, we're running all 5 fans at the same RPM, and we would just control that up and down. In the event that we want to remove a fan, mainly for maybe it's oversized or to get more efficiency out of the system, we would just have somebody remove that fan out of the array and then put a blank off panel, and then make, instead of a 5-pack, we would run on 4 and speed those fans up a bit more. But in the event of a failure, that lost fan, the other fans in the array will spool up to compensate for that loss anyway. So it really just depends on how the application would go, but all of that sequenced through our controller, either through the BMS signal come in from a 0 to 10, or from the hand potentiometer mode that we have.
Perfect. Couple more questions for you before we move on. Brad is asking, it's safe to assume that all factory installed wiring is UL, CE, CSA approved and listed, and there should be no issues with the local on-site inspectors.
Yes. Everything I think is UL 507. I believe, Kurt, if you're about there, you can confirm or deny. I think that's what it is. We have all the UL certificates. It's ETL and UL for everything on our wiring harnesses.
And Kurt is posting that in the chat.
Okay. Yeah. All right. Good.
Nathan also asked, while Kurt's answering that, will the premium controller provide backnet alarms when any of the fans fail?
Yes. So on a premium controller, you'll get individual fan alarms. So it'll tell you exactly which fan has failed, not just at the display, but it'll read it back to the BMS. It'll even give you a code of what particular failure that is. The fans have about 7 alarms built into their electronics to prevent alarms from over voltage plus 10%, under voltage minus 10%, lock rotor, over temperature of the electronics, over temperature of the motor, and then you can set some other limits as well. You can have an RPM limit, but the fans also have a lock rotor as well to prevent anything, and all those codes can be read back through the BMS.
Perfect. And Kurt got back to us. So the control panels are listed at 508A listed, and the entire product from the QCB to the harnesses to the fans are listed under UL 1995.
Perfect. There you go. And a lot of things that we talked about previously with all the components aren't just for medical and hospital facilities. That's what we're focusing on here, because I believe those are very critical components and problems that it solves, but it also does it for any other application as well. And one of the things I like to talk about is how quick these things are to install and repair. Mainly because downtime, a lot of these jobs end up being at odd hours when hospital facilities are kind of at not peak. So they do schedule shutdowns at like 3 o'clock in the morning or on a weekend. And typically it takes longer to take out of the existing blower than it is to install the Q-PAC system. So this is a case study we did for a healthcare facility in Nashville, Tennessee. It happened right in the height of COVID. And their whole 8th floor that they were bringing back online had gone down. And so they had asked us to quick ship it, and they needed it less than like 3 weeks. They were limping it along with spare equipment. And so we were able to build that in, I think, less than 2 weeks. It was like, it was 2 days. Like, we did it in 48 hours. We had all the components built and shipped to them, and then they had it installed after they removed the old equipment and had it installed like with less than 4 hours. And it's such a really cool story because this happens a lot with people. They push off maintenance, or it gets to a point that something breaks and they have to have it, yesterday. And while it does cost a bit of a premium to build something in 24 to 48 hours, we have that capacity to do so. So in the event that you run across an application where they're like, hey, this thing's down, I got to have it. Can we have it in 24 to 48 hours? The answer is most of the time, yes. We manufacture everything. It does stop kind of our production, which is why the premium comes in. But you could call us, like this morning, you could have called us and said, we need a 5-pack system, and we've got a PO, and we would probably have it built either tonight or ready to go out of the shipping on Friday morning to be ready to go out to the facility. We also did that for a facility in Jacksonville, Florida, for a surgical center. They called us on a Wednesday. We had it built by Thursday afternoon, and they were tearing the unit apart on Friday and had it up and running by Saturday. So, I mean, this is stuff that moves pretty quickly, and this is exactly what we're kind of geared to do. So if you think it sounds ridiculous to ask somebody to build something in 24 hours, like, give us a shot. I guarantee you we could probably do it.
Also, a bit of a shameless plug on us right now. Our standard lead times are 2 weeks.
Yep,
so
that was next.
We have that, yeah, I was going to say we have that capacity all the time.
Yeah. So right now, like Eddie was saying, is our standard lead time is about 2 weeks, 2 to 3 weeks. And it doesn't matter how big the system is. It could be 15, 20 fans, and we would still be able to accomplish that. We have such a great team, that just in, not just in production, but also from the engineering side as well, that our selection software is sort of just miraculous. Like, you can build a system, price it out, and, put the order all in there at the same time, and then have a system built within 24, 48 hours on a quick ship, or, within 2 weeks for regular planning. So we're probably the industry leader. And if not, I'd like to see who could do better than us. And I would say that most of our applications fall with that 50,000 CFM or less, what we would call like a 9-pack or less. So it's got one quick connect box. Normally I would say they're probably around anywhere from 3 to 6 fans is kind of our bread and butter size, which puts you in that 10, 15,000 CFM up to maybe about 30,000 CFM. And the fun part was, what we're talking about, like 2 to 3 people that can install these, is you don't need your highest technician level to install these. Normally it's one technician to supervise, maybe run the electrical, and then like a couple of helpers. So it keeps your labor costs down from a mechanical side, from an installing standpoint, that, you can have a couple of people get this done. It's easier than building IKEA furniture. The panels all snap together. They're all labeled 1 through 7. So it's very hard to mess it up. That comes with a very easy to rebuild sheet. And even in the worst case scenario, we can always make a phone call down to our facility, and we can walk you through how to build or do the startup on those particular components. So, because the minimal connections that an electrician has to make, it's right there.
Yeah, on our YouTube channel, you can actually see a couple installs that we've done, and they are sped up, they are time lapse, but you can see the actual true running time at the bottom, so you can see that these things can be done that quickly.
Yeah, and for those that shameless plug to talk about our Impact Summit, a perfect time to come down and see how these systems get built. I believe we'll have a demo system that you can kind of see and be able. I'm sure we'll be able to take fans on and off and kind of show you how this all works in a more live presentation. And I would challenge anybody to that's built one of these or had a customer build one of these is kind of spread the word. Word of mouth is always a big thing. And people that do these systems are blown away by how easy they are to install. And one of the things we'll talk about here, just kind of the last little bit, is about energy savings and ROIs. This is a big kind of talking point for a lot of facilities, where if they're going to make the investment to change technologies, what's in it for them? And we did a case study or I did an energy calculation for this facility in Lubbock, Texas. Again, it was 30-something years old, that the existing building had 40 to 75, 60 horsepower motors in there. When we were doing the retrofit for these particular systems, we ran the calculations to show them that they were almost, in some cases, like 20 horsepower heavy, that we were able to cut out a lot of that to do the exact same amount of work, to do the exact same amount of pressure, and save them upwards of 40% on their energy costs just from a straight horsepower perspective, and give them an ROI of less than 3 years. And that was just purely from a paper to paper like extrapolation based on their kilowatt hour rate. Once that system was probably put in, it's even higher. It's probably even higher than that, depending on their demand level. So a lot of times when we're talking about ROIs for these particular systems, what I would consider standard HVAC between about 2 inches of static and maybe less than 6, 5.5, somewhere in that ballpark range. That's the bread and butter of these fans, like efficiency standards, right in that window. And a lot of those will give you ROIs as low as 12 to 48 months, depending on operating hours, run times, things like that. Because when we're looking at an AC motor with a VFD, depending on whether it's a belt drive system or even a direct drive system, when we're talking like fan efficiency indexes or how to compare like for like, I like to normally talk about total fan efficiency. And total fan efficiency takes away the motor component of it as a whole. Looking at something like a Baldor or a Marathon or a WEG motor, those motors will say on the data plate they're somewhere between 88 to 92% efficient, but that's at full load. They don't know what they're putting on the front of that motor. It could be a pulley, it could be a wheel, it could be a pump for all they know. So now you've got a motor from one manufacturer, a wheel from another manufacturer, a hub or a shiv, belts. So you've got all of these losses that come through your system: transmission losses, drive losses, electrical losses. So when you're talking like double width, double inlet blower style solutions, you're somewhere in the total fan efficiency grade of about 15 to maybe 30% of a total fan efficiency. Direct drive systems can improve on that. And they're somewhere between about 28 to 42%, somewhere in that ballpark range, depending on if you really got a really good wheel. You can probably bump that up a bit more, but that kind of stays in that range with the drive loss. And then you look at EC fans that can be somewhere between 35 to upwards of 70% total fan efficiency, depending on where it operates on the curve. So in a lot of ways, you can double your efficiency just by going to EC. And so that pays back in kilowatt power and horsepower. That's why you'll very rarely see a lot of these EC fans are somewhere between 5 horsepower and 10. We just use multiples of those to achieve what we need. So when we're talking medical facilities, these are just a few more, and touching base on that ROI is like somewhere between 30 and 40% is not an uncommon energy savings. We've done case studies in other industries through other buildings and jobs that we've done that we've seen upwards of 60% plus energy savings. A lot of times when we do these retrofits of these systems, the way that the airflow is now designed to pull through that coil more efficiently, than instead of going around a double width, double inlet blower housing, you're going to see a savings on your static pressure. And so being able to, instead of having maybe 4 inches of static, you're running it maybe 3 1/4. So we can slow the fans down a bit more and get more efficiency out of that system. And you'll see these savings go around as they start to test and balance these systems. And there are ways to even make those systems more efficient by either, like if we're oversized by a little bit, by removing a fan and having a spare fan just inherently at the system. So these are things that we can do, and we can run calculations and show these numbers based on their kilowatt hour rate and what is existing and what we would put in the system based on our submittal.
Perfect timing.
That was to say, look, I think I've done this before.
Like I told you all, he's a one-stop shop. So let's see if you can help Nathan here. Nathan was asking, what's the largest CFM rating these systems could be implemented in, especially in a plenum setting?
We've done systems upwards of 150,000 CFM plus. As long as there's enough space in the Airstream, there's no limit to the CFM capabilities. It may be when we're talking about how many fans we can put on a single point of power. I think upwards right now it's about 250 amps, so that's somewhere between 20 to 27 fans on one controller. So that's really where we're limiting. Like we've done systems that were 40 fans and upward to 60 fans, I believe, is the biggest system we've ever done. So if you think 3,000 to 5,000 CFM with a 60 fan system, you're talking 300,000 CFM systems. So really, it's just we're just limited on the space.
Right. The beauty of scalability. And then David had a question. Hospital AHUs often have UV lights on the backside of the coils, which could be right in front of the fans. Is there any concern with the UV lights and the plastic fan blades that some of the fans use?
No. So these are like a polyamide fiberglass reinforced plastic. So even in the event that the UV lights could over time have some kind of degradation against the plastics, that would still be covered under the warranty that we would provide. Normally what I would probably, because we don't offer inlet screens anymore. Normally that's something that a mechanical contractor could do at a much cheaper cost than it would us to order that stuff from the manufacturers in Germany. It would be like parts flying in and upsetting the fans from a balance perspective. Not all fans have a plastic impeller. It really depends on the manufacturer that we use. A lot of them are aluminum as well. When we're talking higher static applications or going to a particular manufacturer like Rosenberg, they don't make a plastic, what we would call a plastic impeller. It's aluminum. So it would really depend, and we have those options that if that was a concern, that we could pick a specific material that we would need.
Yeah, we were at the BOMA convention a couple weeks ago, Kurt and I, and we talked to UVDI, and they were talking to us about that. And they said they run tests on all these things, and that the only thing they notice is maybe some slight discoloration, but no loss in functionality on any of the composites or anything like that.
Yeah, you'd have a tie-dye wheel. It'd be unique.
Yeah, another pro.
You never see it from the front side anyway. I mean, unless you're cleaning the coil, you don't. All the accessibility on the fans is on the exhaust side. So once that array is built up, you very rarely ever have to go to the front side of that bulkhead unless you're working on the coil side.
Yep. Another question from Ahmed. What is the sequence operation for multiple fans?
So it's very similar to whether it be 1 fan or 9 fans or any more. The 0 to 10 input scale is daisy chained out to the disconnect, from the disconnect to the quick connect box. And that 0 to 10 input scale, whatever it would be, we'll just call it 7 volts of input. That 7 volts would then be distributed out to all the fans via the wiring harnesses in the control block. So everything is made like if we have 1 quick connect box, we have 1 terminal block, and that could be up for 9 fans. So every quick connect box can handle up to 9. So depending on how many fans would be in that system would be how big that quick connect box would be, but they all get the same mirrored signal. So even if a fan were to fail, it's still getting sent the same signal as you're just getting an alarm reading back from the fan itself. There's really no major sequencing. For you wanted to know what all the controls are inside the controller, that would be more for our technical department to tell you how they run through different relays and through the PLC.
Yeah, and while we wait for any more questions to come through, we'll just highlight again, we've talked about it a few times, but our summit is going to be October 18th and 19th at our facility. We'll be doing demos, showing off the product. You'll be able to actually interact with an FS1 system and see it in production, and see how it goes together, the pieces. We'll let you touch all the fans, do all that kind of stuff. We'll have keynote speakers. I believe Zeal, Abeg, and Rosenberg will both be presenting, as well as Kevin Kelly from Florida Applied, and Amanda Holmes, who's a great business leader, business mind from Chet Holmes International. She'll be giving a presentation as well. Happy hours, networking events, the works. We're also not very far away from golf, the beach. It's October. It's not a bad place to be. And then it looks like we have another. Oh, that's from our new sales guy, Leo. So he was saying from a UVC standpoint, you wouldn't want to place the lamp at the inlet of the fan. If the lamps are magnetically mounted to the bulkhead wall, avoid the inlet directly. So that kind of gives us a really dialed in approach to the question from earlier. Any other questions we may have? We'll sit here for a couple minutes. That's an old slide. Our next unPAC will be in August. We're determining the date now. We have some things to move around between shows, but that one will be kind of doing the same thing we did today, but we'll be highlighting universities and school facilities. So that'll be another great way to show the application, the challenges that those facilities present, and ways that we can provide a solution for you. It's a great time to ask specific questions. I'll be sending up a follow-up survey after this. So if you have any questions that would relate to that topic, or ones we didn't get to today that you think of later, please send them back in that survey. We'll be happy to get in touch with you directly, or highlight them in the next unPAC. Looks like another question from Ahmed is, controller can connect with BMS system or thermostat? So I think that's a pretty.
So the typically it's through a BMS system, but it can run off of anything that provides a 0 to 10 input scale. So whether it be a humidity controller or a temperature controller, pressure device, whatever is providing a 0 to 10 input scale, can be plugged in through that. So if you want the fans to ramp up and down as the temperature, and you don't have a BMS, that's perfectly fine. We have a lot of jobs that don't have building automation, and they just use a standard like 0 to 10 generator that'll run off a thermometer or a thermostat or a humidity sensor or even a pressure sensor. So it doesn't really matter. You just have to make sure that your scale is set. Sometimes the offset of that 0 to 10 may need to be tweaked to figure out what the balance would be.
Great. So yeah, we will, like I said, we'll sit here on a couple minutes if anybody has any questions or wants to linger around and post anything. But other than that, thank you again so much for joining us. These are really fun. We had a lot of great interactions today, a lot of great questions, and happy to continue bringing you all this content. Hopefully we answered a bunch of the questions and applications and challenges that you have out in the field. And you stuck with us for an hour, so mazel tov on that. Thank you very much.
I keep it under an hour.
You did fantastic, Aaron.
People have places to go,
shop, my friend. We'll see you at the summit, Alyssa. Thanks for everything. David asks, tell us how to best log and evaluate the performance.
So, I mean, that'll vary depending on what it is you want to log. So inside the controller, you can do power readings, CFM readings. All of that can come back to your BMS. Sometimes when we're doing an energy analysis from the old equipment to the new equipment, we'll put like a power meter or a data logger or something on there so we can kind of see what the unit is running prior to a retrofit and then after, to give us a really, really good idea of what their energy savings are in live real world numbers. The controller itself is I would say it's limiting, but I mean it gives you enough information, but you'll be able to pull that stuff out through the PLC if you really wanted to do any kind of logging or power monitoring or anything like that. But if you really want to log and evaluate that stuff over a long period of time, I would recommend like having a specific data logger for that particular information, so you could really tailor it to what you want.
I think everybody's staying because they're just afraid to go outside. It's so hot. We'll give it one more minute. If anybody has questions, like I said, look for that survey that's going to be heading your way shortly. It'll have an opportunity for you to ask any questions that you think of later, as well as any ideas or any considerations you want us to make when we present universities in August. It will also reference, like we continue to do, about the Q-PAC Summit. So you can scan the QR code at the bottom. You can email the marketing email that's at the top. Or you can follow the link that'll be at the end of the survey, and that will actually show you the landing page, which has a lot of information, shows who our sponsors are, things to do in the area, and then kind of give you a quick rundown of what the schedule will be. So excited to have you all there in October. All right, everyone. Well, thank you for joining us. We are going to end the broadcast. It's been great doing this with you, and we will see you all in a few weeks. Thanks. Bye, guys.